Hi everybody, this is Mr. Beckstrom, and today I want to take a look at an example in section 6.4. It says graph the function y is equal to 6 sine of 1/6 x. Show at least 2 cycles and use the graph to determine the domain and the range of the function. So for this one here, the first thing I want to do is I want to look at the general form of this equation. Y is equal to a times the sine of, and here I'm going to use omega x like this. And oh, kind of messed up my look. That looks more like an M, doesn't it? Let me change that right there. Sine of omega x. All right, it looks a little bit better. So sometimes you see this as a B, depending on what example or book you're looking in. But from this here, we know a couple of things. The first thing we know is that our amplitude, and I'll just write it as like this, our amplitude is equal to the absolute value of A. So that's going to be equal to the absolute value of 6, which is just going to be equal to 6. And our period, that's going to be equal to, is it 2 pi over our omega? So that's going to be 2 pi divided by 1/6, which is going to be 2 pi times 6, which is going to be 12 pi. 12 pi. All right, so this gives us some information about it. If we're going to draw this, and let me use just way out there. So let me use a ruler here. Whiteboard has its perks, but it is also some issues. So if I draw a straight line here, and so that's my x-axis there, and let's draw the y-axis here. And we know we're going all the way out to 12 pi, and they want us to do at least 2 cycles. So I will do 12 pi here, and I'll go out here and say that this is 24 pi to make sure I do 2 cycles. This has an amplitude of 6, so I know I'm going all the way up to 6 and all the way down to -6. That's what my amplitude tells me. And I'm not doing any reflections. I'm not doing any phase shifting because there's nothing adding or subtracting to that x, and then there's nothing adding or subtracting to the actual function itself. So this thing looks just like a normal sine function, which means that we're going to still start at the origin here, which means that halfway through and halfway through here we should be hitting that x-axis again. So we should be going up, coming down, going down, reaching that -6, coming back up here, so making a full rotation there, and then I'm going to hit my work there, but that's okay. And then coming down, oops, pretend that, and then going all the way down and coming back up like this. So it should look something like this, and it's going to go that way too as well forever. And this thing is just going to keep on going that way and going this way. And remember, this is a periodic function, which means that it repeats in both directions infinitely. So from what I know about sine functions, this is what it should look like, just based off the information that they're giving me. And now I want to use both my graphing calculator, and I'm actually going to use Desmos graphing calculator to kind of verify that. So let's do the graphing calculator first. It's just good to do some practice on that. So I am in radians here, so I want to make sure I change my mode. So mode, I am already in radians right here, so we're good. So let's go ahead and go up to y equals, clear that out, and I'm going to do 6 sine, and I'm going to put this in parentheses, 1/6, like that, and x, and close parentheses. And let's go ahead, and if I graph it, it probably is just going to give me something like this. So I want to set my window in order to get this whole graph in it like that. So I can do that manually. So I'm going to go over here to window. So my x, I'm going to go from probably just a little bit to the left of 0 here. So let's start at like -1. And to the right, look at this. I want to go just to a little bit right of 24 pi. So I'm going to be a little clever here. I'm going to say 24 second pi plus 1. Plus 1. Just a little bit to the left of 0 and just a little bit to the right of 24 pi. I'll leave the scaling alone. And then for my y's, I want to go just a little bit lower than -6. So we'll go with -7. And a little bit higher than 6, so we'll go 7. And that hopefully should get this in our graph nicely for us. 2 complete cycles, 1 and 2, and it does. That looks beautiful. I probably, if I wanted to, I could change the scaling maybe to like 5 here. I can leave that Y scaling alone, but make it look a little nicer there. You see that instead of being all bunched up. But yeah, that's how we do it in our calculator. So that looks right. It kind of confirms my hand sketched graph there. And now I want to use Desmos. So I am going to go to Desmos. Pull this over here, and y equals oh, y equals 6 sine of 1/6, oops, 1/6 x. All right, now if we go out here, and did we put that in right? So it should be, it goes up to 6, right? 1 full cycle there, 1 cycle there, and it stops right around there. That's 70 something. Is that what we said it would stop at? 24 pi. Yep, because that's 3.14 times that. So all looks good. So this is how we go about doing one of these. Now with the cosine, it's going to be a little bit different because remember the cosine normally starts at 0, 1 and goes down. So so that's going to be transformed accordingly that way. And all right, if you have any questions, let me know, and I hope you have a great rest of your week. Thanks.